Set up an equation and solve it. Find three consecutive odd integers such that the product of the first and the third is 71 more than 10 times the second. So again, if we wanted to come up with three consecutive odd integers, we'll call the first one x. The second one, we have to skip the even number, so we're going to add 2 to get to the next odd. And the last one, we would add 4. So these are our three consecutive odd integers. And now we want the product of the first and the third. Well, the first one is x, and the third one is x plus 4. So we'll multiply those together for the product. Is the equal sign. 71 more than is adding 10 times the second. Now, since the second is a sum, I'm going to use parentheses. Let's clear out all the parentheses. We have x squared plus 4x is equal to 71 plus 10x plus 20. Combining like terms, x squared plus 4x is equal to 10x plus 91. We have a bunch of variables. We need to try and get those together. We can add a negative 10x to both sides of the equation. But you notice we'll still have two variables, so let's also add a negative 91 to both sides of the equation. And that will leave us with x squared minus 6x minus 91 is equal to 0. In order to solve this problem, we'll use the zero product property, multiply two things together so that it's equal to 0, and therefore one of the factors would have to be 0. So we need the factors of 91. 1 times 91 and 7 times 13, which are 6 apart from each other. So we'll use that 7 and that 13. The signs are supposed to be different. The result is supposed to be negative. So if I have the 7 as a positive and the 13 as a negative, that will work for us. We'll take each of these factors and set them equal to 0, and then solve these two simple equations. Leaves us with x is equal to negative 7, x is equal to 13. So again, this is a word problem. We need to answer in words. The three consecutive odd integers are negative 7, adding 2 would be negative 5, and adding 2 more would be negative 3. Or, and since they didn't specify even, positive or negative, we'll also go with 13. Adding 2 is 15, and adding 2 is 17. So we have two sets of three consecutive odd integers that makes this situation true.